Okay, in this second video we'll show you how we can do the inside and also mirror image this so that we can get to it. So this is the original drawing. What we need to do is we need to get rid of the profile that we created, so we can do that using NC Gallery and delete it. Okay, so that's got rid of the profile that we created earlier. Now we need to redo the geometry. Given that the drawing is in this orientation, it's easiest for us to create the geometry and then do the mirror imaging. I'll just set my line width back and set my layer back to the standard layer. Okay, so now we can just do some more line parallel to this. So we'll do a line parallel to the end one, which is 10mm to the right, and then parallel to that one, which is 3.6 to the right. Okay, so that's done those. Now we can do the bore. So let's do the bore in the center first. So that's going to be 12.95 divided by 2 above. That's taking into account the tolerance. And the next one is 17.14 divided by 2. And the third one is 28.05 divided by 2. Okay, so that's the lines drawn. There are a couple of little fillet rods which I need to put on, but first of all I'm going to zoom in on that area so I can see what's happening. So I use the intersect command with clip items. And now I use the fillet command. Radius is 0.4, so we need a fillet there. And need a fillet there, back to intersect to finish that off. Okay, so we've got that part drawn, so now we can mirror image that. So if we go to select and just check that we've got everything selected, so we need to mirror image in the x-axis, click and drag around the area, and then in near snap make sure we indicate that point. So that's mirror image the geometry. Now what I need to do is, because my Z0 needs to be on the outside edge here and on the center line, I need to create a point there, so I can do that by using intersect, create a move point. So if I create a point where that line intersects that one, then I can attach the datum point to that. So to create the profile for the internal operation, first thing is to move the datum. So having selected the NC button here on the left hand side, I can say set NC datum and I can move, so that now becomes my Z0. So now I can create the profile, and in this case the profile will be closed. Okay, so the start and end point of the profile is this back corner here. It's best to use the back face when you're creating an internal profile rather than the front face. Okay, now even though we're not going to be machining these parts here, it makes it easier just to create a single profile of the whole thing. In this way it's clear that any material contained within this shape is the material, and anything around the outside is free air. So now we can take that, we can save that away, and I'm going to call that number 3, and we'll take that through into machining. Check on my tool change position, that'll be okay. Okay, so now there we have the shape with the datum point at the front. So we need to define a boring bar to machine this out. It might be that we need to do a facing off operation along this front face here, and we know how to do that because we did that on the previous video. So it's just a question of selecting an outside turning tool and machining down that face. But for what we want to do here, we want to have a boring bar. Now a boring bar, you need to be careful that you get the mounting correctly. So the first thing is that it's mounted on a rear turret, but it's approaching from the front. So the approach can be front or rear depending on whether you want to machine above or below the centre line, but the turret must be set to where the turret actually is. Rear above the centre line or front below the centre line. So this is the boring bar, and we'll give this a smaller cut depth, and then we'll select that tool for use. Constant surface speed 150 meters a minute, feed rate 0.1 per revolution, and the coolant on. So having done that, we use the same commands as we've used previously: facing, turning and profile turning. So in this case we'll use the facing command to start just on the centre line there, or just to one side of it, and there. Finishing allowance we'll leave. Okay, switch on tool animation. If you needed to drill the part before you put the boring bar in, then on the toolbar here you set up a drill tool and just simply give it the depth that you want to drill it. Okay, so that's roughed that out. We might now need another tool with a smaller tip radius to do the finishing. So we choose tool, boring bar, again we'll give it a smaller cut depth, and we'll change the tip radius to 0.4 because we have a 0.4 internal radius on one of those corners. So that sets up the tool. We now need to select it for use, spindle speed, feed rate, and now we can do a profile turning operation to machine that shape. So if I just leave all the options as they are and just click OK, you'll see what will happen. So it is possible with that boring bar for it to machine that round the front face of there and go all the way round there. If we don't want it to do, then we need to limit the number of spans. So if we click on the options tab here, we switch on number spans and it tells us the spans that are there. So now we can go back and modify this profile turning operation, and we'll end the machining at span number 7. So if we now simulate that, we can speed up and slow down the display using the counter on the right hand side here. So if we slow it right down, so here comes the finishing boring bar. Okay. Now the default options on there is to leave an arc approach and an arc runoff around there, but they can be modified via the approach and runoff options here. So you can set the style and you can set the size. So with the tool where it is here, we need to take the tool out. So we can use the go to command to send the tool to its home position, and in this case we must ensure that we choose move Z axis first so that it comes out of the component and then goes away. Otherwise it would do a rapid 2-axis movement right through the job. So if we're happy that that's all doing what we expect, we can run the simulator on that. We don't need to worry about any of the options on the simulator, we can just simply run it. Okay, so that's run the simulator on that. So if we're happy with that, we can go back, exit the simulator and post-process. And okay, so when we post-process, that produces the G-code file, and it will be in the same folder that the original drawing and original machining program were created in. If I just show you that again, so this is where we choose the post-processor. The output file name will be the same as the original drawing and machining programs, but it will have the extension .pun. So that's the G-code file that you send to the machine, or if you need to put it on a memory stick or do something like that, then you can easily change the extension to .txt. Okay, so that's how you machine that part.